look something like that. You have 2 inches there. Four inches there. Producer there, 4 inches there. Three inches here.
Right. That's the exact same thing as you just did.
3 inches there.
Would that be the exact same thing what you just did?
Yeah, it's just taking off.
Except the circles down the middle, it's just cut off the edges.
Yeah, it's the same thing.
Except for it's not 4 by 4,
Well, yeah.
right? Right, so it is very similar. What's more difficult about this one is now this one requests find IX and IY. That's what makes this one more fun.
Okay.
That's just gonna make this one a little bit more challenging. Okay, so what's our strategy? So the strategy is, hey, I wanna take this larger rectangle and I wanna subtract out one on this side,
Half
and I wanna
side.
subtract out one on the other side. That's what I want to do. That's sort of the strategy. Alright, so let's say that I called this an A and this a B and this a C. Alright, so I'd like to subtract, I'd like to find IXA. Base times height cubed. What do I have down here? 12, thank you. So base, what number? Height, what number? Yep, so we got 6 here, 8 here. 8 raised to the power 3, 512. Times 6, 3072, divided by 12, 256. IXB. Alright, we talked about this one tonight. Where's the center? Where's the center of one of these semicircles? Somewhere about there and somewhere about there. Okay. So which one do I use? We got a .1098 and we got a pi r to the 4th divided by 16. Where is the bounding edge and where is the axis? Okay, just for conversation's sake, I want to back up to this page right here. You know, cover it up, we're gonna look at it. Oh look, here's a bounding edge, it's parallel to the axis. Oh look, here's a bounding edge, it's parallel to the axis. Here's a bounding edge, it's parallel to the axis. Here's a bounding edge that's perpendicular to the axis. A bounding edge perpendicular. Edge, perpendicular, edge, perpendicular. Relative to the x-axis, where's this bounding edge? Or this bounding edge? It's perpendicular, isn't it?
Yeah, it is.
Y,
Oh, yeah, but why is it?
to X and Y.
Because we're looking at the x-axis, not looking at the y-axis in this one, so then we use this one, this equation.
So you can't just actually get the area of the circle and subtract it out like you did before?
No. Well, I mean, we could if we were looking at the area, but we're looking at the moment of inertia, so we will use the area, but we'll use it in regard to the y-axis is where we'll use it. Alright, 2 raised to the power 4, 16 times pi, 50.2 something, divided by 8. 6.283, 19 inches to the fourth. Okay, so IXB is IXC, they're gonna be the same. So IX, nice and boring, 256 inches to the fourth, minus at 6.28319, minus 6.28319. Let's see what we get. Minus 2, negative, plus. So I sub x is 243. 434 inches to the fourth. So IX, nice and boring. IY, oh, then things start getting a little bit more interesting. So if we're gonna do IY, now I need to know where's the center at relative to the y-axis. Because where was the center of the semicircle relative to the x-axis? On, right? So what was the distance? What was my c distance here? 0, 0. So for the x-axis, there's nothing exciting going on, but for the y-axis, well, then things get a whole lot more exciting. What's the area for B? Pi r squared would give us a full circle, so we want half of it. Radius is 2 inches squared, divided by 2. 2 squared is 4, times pi divided by 2. 6.2831. More 9 inches squared. That's our area. Why do I use 4r over 3 pi? What's the purpose of that? What does that tell me?
Center of the area.
It tells me where's the centroid of the semicircle, is what this is telling me. Where's the centroid of the semicircle from the straight edge? So 4 times 2 is 8, divided by 3, divided by pi. 0.8482. One more, 6. Okay? But that's from the straight edge, right? That's not from the y-axis. Right, so I need to take 3 minus 0.848826 inches. 2.15117 inches. Okay. I sub y for shape A. Base times height cubed divided by 12. In this case, the base will be 8. The height will be 6. So let's see what we get there. 6 cubed is 216 times 8 is 1728 divided by 12, 144. IYB now gets interesting, because in order to find IYB, I need to use the parallel axis theorem. So we need to do this thing right here. So we got that 0.1098 radius to the fourth. So you go 4 up here, that was perpendicular. For this one, the bounding edge is perpendicular to the axis. Now for Y, the bounding edge is parallel to the axis, so now I use this one. Did I ever figure out the area?
Yes.
Yeah, 6.28319 inches squared. Did I figure out the C distance? 2.15117. Oops, it's on inches squared up here, that's just inches. So here we're gonna square it. Alright, so the 0.1098 times the radius was 2 raised to the power 4. 1.756 1 inches to the 4th plus 1 times 2.15117 squared. 29.0756 inches to the 4th.
Slide it up, Melvin, a little bit.
Sure.
You're right.
My other pages are sort of fighting me a bit there. So my IYB ends up to be this 30.8318 inches to the 4th. So now if I want to find IY, I need to take the IYA, 144 inches to the 4th, minus 30.8318 inches to the 4th, minus 30.8318 inches to the 4th. Times 2, negative, plus 144. Sorry, I'm gonna slide this down so I can go to the next page. And I realize that we're done, so I'm just gonna write this answer on here and I'm gonna write the homework down. 2015, 13, so I sub y was 82 and 82.3365 inches to the 4th. Homework. Chapter
5.
5. So let's see. I think I assigned section 5.1 and 5.2 last time. We just assigned 5.2 last time.
Yeah.
It was 5-2.
Okay, so we gotta do section 5-3 evens. Is that 5.4? Yeah, we started on 5.4. Attempts. 5-4 evens. Okay, so go after those.